Dear student, today we will discuss probability theory. So, now what is probability? So, first of all, probability is nothing but it is the chance of happening an event. So, in probability theory, we will study the laws of probability. Now, what is probability or what are its laws? The word probability, which is also known as chance, is commonly used in our day to day life. So, the word probability or chance is commonly used in day to day conversation. And if we take an examples, then you will see many sentences like probably it may rain today, or the chances of team A and B winning the match are equal, or will a head come up or not when a coin is tossed? So, in all these cases, the chances of happening an event is uncertain. We are not sure about it. And we talk of in terms of probability, which is nothing but a quantitative measures of chances or uncertainty. So, you will see in all the events are uncertain, and we are talking about probability, which is a quantitative measure of uncertainty. So, probability in probability theory, systematic founded by a French mathematician, Blaise Pascal, and has become an essential statistical tool which solves many problems related to biology, related to social sciences, related to economics, and related to the political domains. So, in this lecture, we will study how to compute the probability of an event and what are various laws of probability. So, this lecture is divided into two parts. First part contains the theory part, and then we will demonstrate all these theory with the help of example. So, first of all, we will introduce few terms which are related to probability or random experiments. So, some important terms which we will use in subsequent section of this lecture. First one is what is trial and what is event. So, trial is an experiment which is performed under some homogeneous conditions with various possible outcomes. And the outcome may be, if you are tossing a coin, then outcome of this experiment is it may be a head may come up or the tail may come up. So a trial is an experiment performed under identical condition with various possible outcomes, and it is known as events. The outcome of an experiment is known as events. If we take the example, then if we throw a unbiased dice, so throwing a dice is a trial, and getting an odd number is an event, or getting an even number is an event. So if we throw a die, it is known as trial. This is known as trial when we throw a die. Throwing a die is trial, but getting odd or even number is an event, right? Then next term we will use exhaustive event. What are exhaustive event? So the total number of possible outcome in any trial, the total number of possible outcomes in any trial. If you take example of throwing a dice, then the possible outcome, one may come up, two may come up, three may come up, four, five, and six. So if all the possible outcomes are listed, then they are known as exhaustive number of events. And if we talk about throwing a coin, then head may come up or tail may come up. So head and tail are, if we consider both these, then they are the exhaustive number of event in tossing a coin. So in throwing a dice, there are six exhaustive outcomes, which I have already explained. It may be one, two, three, four, five, and six. The next things comes up is the favorable event. So the favorable events are those events or those outcomes that lead to occurrence of an event. For example, if you talk about or talk about the throwing a dice, and we are interested in to find out the even number come up. So the 2, 4, 6 out of 1, 2, 3, 4, 5, and 6. 2, 4, 6 are the favorable number of event that even number come up when we throw a dice. Or another example, drawing an ace from a deck of card. If you have a deck of card, then we have 52 cards having four suits, and there are four aces. So 4 is the favorable number of events in drawing an ace from deck of cards. The next one is mutually exclusive events. What do you mean by mutually exclusive events? If happening of one event precludes the happening of other. अगर एक इवेंट आता है तो दूसरा नहीं आएगा. फॉर एग्जाम्पल व्हेन यू टॉस ए क्वाइन, then you will get either head or tail. You will never get both head and tail. So events that cannot occur simultaneously in a single trial is known as mutually exclusive events. A fan may hang up on the roof or it may fall down. So they are, if it remain on the roof or it fall down, will both mutually exclusive event. The happening of one precludes the happening of other. And in case of die, if you rolling a die results in only one phase out of 1 to 6, making them mutually exclusive. It, it will never happen that 1 and 3 come up simultaneously. It will never happen that 1 and 2 will come simultaneously. It will never happen that 2 and 6 will come simultaneously, and so on and so forth. Then next term we will use is equally likely. Equally likely events are those events which have equal chances of occurring in an trial. So outcomes of a trial where each has equal chance of occurring. For example, we will not favor that when you're tossing a coin, the head will come up many more times than the tail. The chances of coming up head and tails are equal, provided the coin is not biased. You may uh, take the example of biased coin in a film Sholay, where Amitabh Bachchan, when tossed coil, always head come up because it is a biased on both sides. The head is there. So if you talk an example, so tossing a unbiased coin, head and tail are equally likely. means there are equal chances of head may come up or tail may come up. Then next important term is independent events. What do you mean by independent event? These are the cases where outcome of one does not affect the other. Events where outcome of one does not affect the other is known as independent event. Means there is, if one is happening, that is independent of other. So you may take the example drawing a card, replacing it, and drawing again makes the draws independent. For example, if 52 cards are there, if we draw one card from this deck of 52 cards, then we have 51 remaining. Next time, the chances of other, if we draw another card from it, then the chances of this card is affected by this card because this event has already been happened. And if I replace this card again to this deck, then this card and this card have equal chances of being selected. Then simple and compound events. So what do you mean by simple? A simple event is single outcome, that is flipping a coin to get heads. And in case of compound events which involves multiple outcomes, that is drawing a black ace, which is both black and ace. Those two events are occurred. One is the card should be of black color and it come up with ace. So this is known as compound event. If single output is there, outcome is there, we call it as simple event. If multiple outcomes is there, we call it as compound event. Then another term is complementary events. Complementary means if one and opposite of it, that is the complementary event. Two events are complementary if they are mutually exclusive. If one happen, then other may not happen. And exhaustive also. So example is same, rolling a dice, getting even number and an odd numbers are complementary events. Then next term is sample space. So sample space is the set of possible outcome of an experiment. In case of tossing a coin, in case of tossing a coin, the sample space will be head and tail. So this is the sample space of this experiment. And if you rolling a dice, then sample space may be 1, 2, 3, 4, 5, and 6. So these are the possible outcomes. So a set of all possible outcomes of an experiment is known as sample space. In rolling a dice is an experiment and one may come up, two may come up, three, four, five. If you club all these things in a set, then it is a sample space. So, example, tossing two coins results in sample space. For example, if two coins are first head may come and second head is also there. First coin head, second tail, first tail, second head, and first tail, second tail. So these are four possible outcomes of tossing two coins at a time. Then this is known as sample space. Clear? So these are the few terms which you should keep in mind when we talk about the terms probability. Now, what is the definition of probability? So we will define probability in two aspects. One definition is known as mathematical definition and other is empirical definition. So mathematical definition of the probability: if a trial results in an exhaustive, mutually exclusive, and equally likely cases, and there are capital N is exhaustive, mutually exclusive, and equally likely cases, and out of these capital N, M of them are favorable to an event E, then the probability of this event E is given by M over N, where we define certain condition that probability of E lies between 0 and 1. 0 is less or equal to P of E less or equal to 1. What does it mean? The probability may be equal to PE, or it may be also equal to 1, or in between. Number 2, the probability of 1, for example, this case happens. What does it implies? It implies that our event is certain. So when you get the probability of an event is equal to 1, then we call it as certain event. And on the other hand, if probability of E is equal to 0, means there is no chance of happening this event, then this is known as impossible event. So probability of E 0 implies an impossible event. Then the classical definition is inapplicable if cases are not equally likely. So I explain here they are equally likely. If they are not equally likely, there is more chance of happening one event than the other, then this definition is not applicable in that case. Number two, the number of outcome is infinite, means there is a large number of outcomes. Then this definition of probability is applicable. Now we will discuss second definition of probability, which is known as statistical or empirical definition of probability. So what is this? If a trial is repeated n number of times under homogeneous and identical conditions, the probability of an event E is the limiting value of ratio of occurrence of E to the total number. So here M is the favorable number of cases and capital N is the exhaustive number of cases, and experiment is repeated under homogeneous and identical condition, then this ratio M over N, provided this N is very large, then the probability mathematically defines as probability of E is limit as n tends to infinity M over N, where M is the number of times event E occurs in n trial, or it is favorable. For example, if you toss a coin 100 times, so you can consider capital N as large, infinity. And out of 100 times, say 48 or 49 times head will come up. So M is your 49 and N is your 100. Then you will take 49 by 100 and limit as n tends to infinity will give you the probability of head. And you will consider few remarks on this definition. The probability of an impossible event is 0 and phi is a null set in which no event is occur. So the probability of phi will be 0. Number 2, the probability of complementary event. Now what are complementary event? If A is event, then the complement of A is A bar. If this happen, this will not happen. So the complementary of an event A is always represented by A bar, and probability of A will be computed 1 minus probability of A bar, because 1 is the certain event, and if we subtract the probability of complement of A, then it will give you the probability of A. So probability of A bar will be 1 minus probability of A, and vice versa. You can, here we will find out the probability of A. When we know that probability of A bar is there, just subtract this probability from 1, you will get probability of A. Similarly, probability of A bar is 1 minus probability of A. If probability of A is given and you are asked to find out the probability of A bar, then just subtract this probability from 1, you will get probability of the complement of A. Then there are certain laws which will help you to find out the probability of the events. So these laws are addition law of probability. What is addition law of probability? Probability of the union of two event A and B. For example, A is an event and B is also an event, and you are finding out the probability of A or B. Either A will happen or B will happen. Then in case of OR, addition law of probability is used. So the probability of the union of two event A and B is given by generally probability A union B. This symbol is known as union, and its formula is probability of A union B is equal to probability of A plus probability of B minus the joint probability A and B. If you subtract this probability of A intersection, this is known as intersection. The probability of A intersection B is subtracted from the sum of probability of A and B, then you will find out the probability of A or probability of B. Now, there are certain conditions. If A and B are mutually exclusive, mutually exclusive means if one happens, then other will not happen. They cannot occur together or simultaneously. When A and B are mutually exclusive, for example, if you, this is Venn diagram, this is event A and this is event B, they are mutually exclusive. One happens, then other will not happen. So they are mutually exclusive. There is no intersection between these two. In that case, the probability of A union B is given by probability of A plus probability of B. In such case, probability of A intersection B will be 0 because they are independent of each other. Then, if you extend this law for 3 events, then what happens? For 3 events, say A, B, and C, then probability of A union B union C, probability of happening A or B or C. So this law can be extended like this: probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability A intersection C minus probability of B intersection C and minus probability of plus probability of A intersection B intersection C. In Venn diagram, if these are the 3 events, for example, this is event A, this is event B, and this is event C. So this is A, B, एंड सी. सो ए एंड बी का ये इंटरसेक्शन होगा, ए एंड सी का ये इंटरसेक्शन होगा, बी एंड सी का ये इंटरसेक्शन होगा, और तीनों का जो इंटरसेक्शन है वो ये होगा आपका. बी और सी का जो इंटरसेक्शन है ये वाला होगा. ये जो इतना पोर्शन है ये तीनों का इंटरसेक्शन होगा. तो इन दैट केस you can find out the probability of A or B or C. So if they are mutually exclusive, like in two events, then these portion will be washed out. So probability of A union B union C will be probability of A plus probability of B plus probability of C. And their Venn diagram will be look like this: A, B, and C. This is A, B, and C. There is no common event in between these three events. And if you further extend this formula for K event, so for K mutually exclusive event, say A1, A2, and AK, then probability of union of A1, A2, and AK will be equal to probability of A plus probability of B plus probability of AK. A1, A2, AK means you just add up all the probability, provided they are mutually exclusive. If they are not mutually exclusive, then formula becomes little bit complicated. The next one is the multiplication law of probability. A and B, A and B and C means both should occur. So multiplication law of probability states that if two events A and B are independent, the probability of both occurring together is product of their probability. So this multiplication law, intersection symbol is used. Probability of A intersection B. So probability of A intersection B is given by the product of probability of A and probability of B. And if you have K events and they are independent, if they are not independent, then formula is different. If there are K events, say A1, A2, AK, then probability of A1 and A2 and AK, and these are independent also, then you will find these probability just by producing the individual probability of these events. Probability of A multiplied by probability of B, A2, probability of AK. And if they are not independent, the probability of simultaneous occurrence is, for example, in case of two event, probability of A intersection B. So it will given as probability of A multiplied by probability of B, and A has already happened. Or vice versa, probability of B into probability of A, it is given that B has already happened. So the probability of B given A or A given B are the conditional probability of B given A, and A given B conditional probability of A given B has already happened. So you keep these formula in mind in order to solve the subsequent questions. How? Let us take few examples that will make more clear picture about the probability. So first example, you should have a bag which contains 10 white ball and 32 blue balls. What is the probability of getting a white ball if one ball is drawn at random? So there are total number of balls. You have 32 blue plus 10 white. So 42 balls are there. Now we are interested in to find out a white ball. So how many white balls are there? We have 10 white balls. So favorable number of cases are 10 and exhaustive number of cases are 42. Take their ratio, you will get the answer. So the total number of balls is 42. Number of Favorable outcomes means white ball you have 10. Then probability of a white ball will be 10 by 42. Very simple. Another example you may take as a box contain 9 red ball, 4 white ball and 10 blue balls. If 3 balls are drawn at random, what is the probability that all are red? Now you will see how many red ball is 9, white ball you have 4 and you have 10 blue balls. So total number of balls you have is 23. Now what you want to find out? You want to find out that all 3 balls which we pick up from the box are red. So how you will find out? First of all, compute the total number of balls. It is 4 plus 9 plus 10, that is 23. And probability of getting drawing a red ball first. Suppose I draw a ball from the box and it is red. So out of 9 red and 23 is the total number of cases, my probability is 9 by 23. Now we will get one red ball, right? Now how many red ball remains? There are 8 red ball in the box. Now out of 20 and here ball remains 22. So out of 22, 8 are the favorable number of cases for red ball. So for second draw, the total ball becomes 22 and probability of drawing second red ball is the probability of R, 1 R has already happened. And we have favorable number of cases 8 divided by 22. So this is the probability of getting second red ball. Similarly, now when you get second red ball, the red ball remains 7 and total remains 21. So after drawing 2 red balls, the total becomes 21 and probability of drawing third red ball is probability that third red, 2 red has already happened. So I have 7 balls remaining with us which are red and total number is 21. So 7 by 21. Now the required proof that all 3 balls are red. First red, second red and third 3 red. So we will use multiplicative law of probability. The required probability for this question you will get probability all red will be 9 by 23, first red, second red and third red, and you multiply this you will get the required answer. Another example you may take as a lot of 100 fountain pen contain 10 defective pens. If 3 pens are selected at random, what is the probability that there is at least one defective pen? You want to select 3 defective pen out of 10 and total number is 100. So if one pen is defective, if 2 pens may be defective, if 3 pens may be defective, you will find out the probability of 1 defective, 2 defective and 3 defective. Or vice versa, you can find out with complementary event. Suppose A is your event which represent that at least one pen is defective and A complement be the event that no defective pen. So you make those 2 events. So let A be the event which tells us that at least one defective pen is there and A bar be the event no defective pen is there. The probability of selecting a non-defective pen on each draw. Again, A bar, since there are 100 fountain pens, 10 are defective. So non-defective is 90. Selecting a non-defective pen from 90 pens out of 100, it is 90 by. Then one is already selected, 89 remaining out of 99. One, two already selected, 88 remaining, 98. You multiply this. Then the probability of A using the complementary law. Probability of A is 1 minus probability of A bar. So 1 minus A bar, you will get the required. Next example, in Delhi, the probability of a family has TV is 0.8. A washing machine is 0.5. And both TV and washing machine is 0.45. What is the probability that a family has either a TV or a washing machine? Your TV or washing machine. You want to find out this probability. And what is given? Probability of TV is given. It is 0.8. Probability of washing machine is given. It is 0.5. And it is also given that both TV and washing machine, A intersection B is also given to you. Yet T intersection W is also given to you. It is 0.45. So this is data with me. And we are interested in to find out probability of T union washing machine. So it is addition law of probability. Suppose A is your event, denotes family has TV, and event B denotes the family has washing machine. So we are given probability of A 0.8, probability of B 0.5, and both 0.45. Now we know that probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. Put the data for probability of A, probability of B, and probability of their intersection, you will get the result. So using addition law, probability of A union B is given by this formula. And probability of A union B, probability of A is 0.8, probability of B is 0.5, and their interaction 0.45. And so it is 0.85. One more example. A student's probability of passing in statistics is 2.3, and the probability of passing in economics is 4 by 9. Probability of passing in at least one of two subject is 4 by 5. At least one of two subject. Find the probability that the student will pass both subject. Suppose in statistics, passing of statistics is represented by A, passing in economics is represented by B. At least one of the two subject, probability of A union B, either he pass in A or he pass in B, is given to you. And you are interested in the probability the student will pass in both subject, means A intersection B. You have to find out this value. So let A the event, the student pass in statistics. B is the event, student pass in economics. Then we are given what? Probability of A is 2 by 3. It is given here. Probability of B is 4 by 9. It is given here. And probability of passing in A or B is 4 by 5. So using addition law of probability, what we get? probability of A union B will be equal to probability of A plus probability of B minus of probability of A intersection B. अब आपको दिया हुआ है A union B, so it is 4 by 5 plus is equal to 2 by 3 plus 4 by 9 minus probability of A intersection B. You have to find out this probability. Then what we do is you just transpose this value to this side and this value to this side. So probability of A intersection B will be 2 by 3 plus 4 by 9 minus 4 by 5. You take the LCM, and so 45 I think is the LCM. So 2 multiplied by 15 plus 5 multiplied by 4 minus 4 multiplied by 9. So it is 30 plus 20 minus 36 over 45. So you see here, right? Then, and on simplification, you will get 14 by 45. 50 minus 36 is 14 by 45. So you can solve such questions using addition law of probability. Then few example on multiplicative law of probability. A problem is given to two students A and B. The chances of solving the problem are 1 by 2 for A and 1 by 3 for B. Find the probability that problem will be solved. So either A will solve or B will solve. They are independent of each other. So the probability that problem is solved is complementary of the probability that both student fails to solve it. This is another way. So probability that A will not solve it. So what you will find out? Probability of A is given to you, it is 1 by 2. And probability that B will solve it, it is given by 1 by 3. And if I want to find out the complement of it, so it is 1 minus 1 by 2, it is 1 by 2. Similarly, probability of B complement, it is 1 minus 1 by 3, it is 2 by 3. So find the probability of their complements. The probability that A does not solve the problem is 1 minus 1 by 2, it is 1 by 2. And the probability that B does not solve the problem, it is 2 by 3. Thus, the probability that both student fails to solve this problem, use multiplicative law, because both events are independent of each other. So 1 by 2 multiplied by 2 by 3, it is 1 by 3. Therefore, the probability that problem is solved is, now again take the complement of it. So probability of solved will be again 1 minus probability that it is both fails, right? So 1 minus 1 by 3 is your required answer, 2 by 3. So the problem will be solved is given by 1 minus if both students fail to solve that problem. So 1 minus 1 by 3, we have already computed both fails. So it is 2 by 3. Another example, a box contains 50 apples, 6 of which are defective. If 3 apples are selected at random without replacement, what is the probability that all 3 are defective? So let A be the event that first apple is defective. Similarly, B be the event that second apple is defective. And C be the event that third apple is defective. Now, what are the probability of each event? Because 6 defective are there. And once you pick a apple from the box, so when First selection is there. You have 6 defective apples out of 50. So this is the probability of selecting first defective. Now we have left with 5 defective out of 49. This is the probability of second defective. And 4 out of 48 is the probability third defective. So each event you will get probability of A is 5 by 50. Probability of B given A is 5 by 40 because you are selecting these event without replacement. So one event has already been happened. So A has already been happened. So it is 5 by 49. Probability of C that A and B has already happened. It is 4 by 48. So the required probability, again we will use multiplicative law. You just multiply these probability, you will get the answer. So this is all about the probability. Thank you. Thank you very much. If you have any question related to this, please ask your teacher or put these questions in comment box. I again request you, if you find these videos helpful, please subscribe my channel so that you can get all the videos and their notification. Thank you. Thank you very much.